Today we are going to look at the natural logarithm and its derivative. So before we do that, I just want to remind you about the logarithmic function you learned in advanced functions and how it is the inverse function to a general exponential function. So let's just review some of those properties. So first things first, hopefully you remember that this is your exponential function. Okay, properties of it, its domain is all real numbers. Okay, range is everything greater than 0. It has a y-intercept at 0, 1. And it has a horizontal asymptote at y equals 0. Okay, so you learned about that one a while ago. And then we added the logarithmic function. So this is our logarithmic function, log little subscript a, that's our base, x. Okay, and remember it sort of had the opposite properties, right? Its domain was just x is greater than 0, yet its range was all real numbers. Okay, instead of having a y-intercept, it has an x-intercept at 1, 0. And instead of having a horizontal asymptote, it of course has a vertical asymptote at x equals 0. Okay, so just like there's a special exponential function, e to the x, there's a special logarithmic function that has little base, right, subscript x. Okay, and of course that would be the inverse function to e to the x, y equals e to the x. And that is called the natural logarithm, and it even has a special notation as well, and we write it as ln x. Okay, so again, pronounced as ln x. Okay, and I'd like you to go ahead and find that button on your calculator. Okay, so once you've found that button on your calculator, just go ahead and punch in these things. Make sure you can use that button. For ln 5, you should get approximately 1.6. For ln 10, you should get approximately 2.3. And ln e, you should get 1. Okay, now why is that? Remember that this is the same as log little e. So really we're asking e to the what equals e, and of course that is 1. So that's one of those sort of important identities that I just want you to list in this box. Ln e equals 1. Why don't you also go ahead and figure out what's ln 1 at this point? Again, this would be like e to the what equals 1. And hopefully you can see that that would be 0. Okay, so that's the button on your calculator. This is just a special logarithm with the little subscript or the base as 2.7, right, our value of e. So all your log laws still apply. So let me just remind you about those. First, we have our product law, right? So this can be written as a single logarithm of ln 30. Okay, then we have our quotient law. This can be written as a single logarithm of ln 5. And then, of course, we can use that power law to rewrite this as ln of x squared plus ln of x to the 3. And then we could use the product rule or product law of logarithms to combine those. So then that becomes ln x to the 5. That's using our exponent, our power law for exponents. That could also be written using that power law of logs as 5 ln x as well. Either or doesn't matter, it depends on what you're doing with it. Okay, so same as all the log laws still apply, all of our solving methods apply too. So here we have an exponential equation. Again, note it's an exponential equation because the x that we're solving for is in the exponent. And if you recall, our method in advanced functions was now we know how to bring that down by taking the log of both sides. So same thing here, we're just going to take the natural logarithm of both sides. So we're going to apply ln to both sides. And why do we do that? From advanced functions, we do that so that we can bring this exponent down using that power law of logarithms. So it becomes 4x minus 2 ln e equals ln 3. Okay, ln e, that's just 1. So really we just have 4x minus 2 equals ln 3, and then we can just solve for x. Okay, so some of these skills are going to become important and come in handy as we're working with the derivative of this function. So let's go ahead and work with the derivative. Okay, so just like the special exponential function e to the x has a fairly simple derivative, ln x actually has a fairly simple derivative as well. So if y equals ln x, then the derivative, then y prime, actually just equals 1 over x. So note there's no actual logarithm in the derivative, which makes it very easy to work with. Let's generalize that. So if we make it a little more complicated and we have ln of a triangle, then hopefully you can figure this part out. The derivative is going to be 1 over the triangle instead of 1 over x. And what do we always have to then do? Multiplied by the derivative of the triangle. So it actually just simplifies right away to triangle prime over triangle, if you want to remember it like that. So let's try some. All right, fairly simple to start. Hopefully you can see that this is our triangle. We do have a constant multiple there as well. Okay. So our derivative, constant multiple, just stays. Derivative of ln triangle is 1 over the triangle. And then go ahead and take the derivative of the triangle, which is just 5. And yeah, we just do a little bit of cleaning up here. We end up with 15 over 5x minus 3. Okay, let's try another one. So when you look at this next one, I hope you can see that this is a big giant triangle to the 5. And then when we kind of, if you want, go inside, we also have ln of a triangle. Okay, so we need to start with our overall chain rule here. Okay, so overall chain rule, so of the red part, if you like, first of triangle to the 5 is 5. Triangle to the 4. Now we're going to go inside and find the derivative of ln triangle. And so the derivative of ln triangle is 1 over the triangle times the derivative of the triangle. Okay, and again, just some simple cleaning up here. Those 3's, of course, are going to cancel. So on the top, we end up with 5 ln 3x to the 4. And we just have an x on the bottom. Okay, so that's the idea here. Let's apply it to some of our other rules and put it all together. I'd like you to go ahead and try C on your own. Hopefully you can see that this is ln triangle. Go ahead and take the derivative of that. Pause the video, see if you can get that one right. Okay, so we end up with cos x over sin x, which of course could be written as cotangent x if you remember that. Okay, and now let's go ahead and do D. Okay, a little more complicated, just putting it all together. Hopefully you can see that you're going to start with a quotient rule, right? So I'm going to set up a big, giant fraction here. I'd like you to go ahead and try that first line all by yourself. How'd you do? Hopefully you got that. Now we're going to do a little bit of simplifying here. I think ultimately you always want anything that is sort of irrational to be over one denominator and not to have, fractions within fractions. So we do want to clean this up a little bit. So I'm going to separate it into 2 fractions. First, just to help us clean it up. So hopefully we can see on the left, we're going to take this little piece and we're going to move it to the denominator with the x to the 4. Okay, so that's our first fraction. We're going to take that x plus 3. We're going to move it to the denominator with x to the 4. We can do that if we're just looking at the left side there. And then on the top, when we multiply all those little pieces, we end up with just a 2x squared. Okay, on the right, we have our 2. Oh, sorry. Let's make that into a 4x, right? From the 2 and the 2. We're going to make that into a 4x ln of x plus 3. All over x to the 4, okay? And I did that because then we have a little bit of simplifying. We can cancel out 2 of those. We can cancel out that x with 1 of those, okay? So then we simply have 2 over x plus 3 x squared minus 4 ln x plus 3 over x cubed. Okay, and just as a final step then, I want you to go back and put this all over one denominator now. Okay, so making a common denominator here, we need an x to the 3, and we need an x plus 3. Let's go to the numerator, the 2. The 2 will just need an x. And the right-hand side of the numerator will need an x plus 3, right? 4 x plus 3, and then we have a ln x plus 3. So that would be a nice simplified version. That's as far as I would want you to go with these ones. Okay, so go ahead and practice some of these derivatives and solving, a little bit of solving, and log laws brought back in there too, just to make sure you remember that.